Find the value of h for each parallelogram. Who's going to tell me how they did it for the first one? How did you find the value of h in the first parallelogram? Phoebe?
I multiplied the two lengths that are perpendicular to each other, so 7.8 and 6.
Okay, so you multiplied the length 7.8 and 6 because they are perpendicular to one another. So 7, Alright, so that's always what you're supposed to do first. Multiply the two lengths that are perpendicular to one another because they're corresponding. In base times height, that gets you the area. So I'm glad that Phoebe pointed out that it was 7.8 and 6 that are corresponding. So that'll get you area equals 7.8 times 6. So what did you get for the area, Phoebe?
46.8.
46.8. Alright, so then where did Phoebe take it next? Phoebe started off the problem. Where do you take it next? Yana?
You do 46.8 equals 6.5.
Very good, Yana. So 46.8 is equal to 6.5 times h, because those would be the other two pieces that correspond to one another because they are perpendicular. So doing all that, what did you get for h? What did you get for h? 7.2. Very good. That is exactly what I'm looking for. All right. I'm just going to give you the answers for the other two because I want to remind you what I said to you about this topic. Okay? This is the commonly missed question on your quiz every single year. We learned this in 10.1. It's example number 2. Okay? Just be warned, quiz on Wednesday. You got to know this type of problem. Okay? It's going to be there. Being honest with you. Okay? So today we're going to get into 10.4. 10.4 is all about finding perimeter areas given that the polygons are similar. Can someone remind me from chapter 7, when two polygons are similar, what is true? Jimmy? Very good. Their angles are congruent and the sides are proportional. Okay, very good. So we're going to keep those ideas, the fact that the angles are congruent and the sides are proportional in order to figure out their ratio of their sides, okay, as well as to find their areas. This lesson does not take that long. We'll take care of our 10.4 check at the end, and then I'm going to get you practicing some content from last Friday with a coloring activity. However, you're not going to get to color yet today because you only know how to solve half the problems. The other half of the problems I'll teach you how to solve on Thursday. Math Excel tonight, due tomorrow. Chapter 8 remediation if you owe it to me, and we're quizzing Wednesday. Here's your advice for the day. I'm kind of starting to run out of advice, so I'm starting to spread them out. Check for understandings actually help your grade if you do good on them, so actually try. All right, here's my big concept for the day. Jimmy already told me if two figures are similar, then their corresponding sides are proportional, which allows me to understand the fact that their perimeters are also proportional. Their areas are also proportional, okay? So the scale factor, if a scale factor is given as A over B, okay, this is their ratio of proportion. The same thing we figured out by getting corresponding sides. So if their sides are in the ratio A to B or A over B, the ratio of their perimeters is actually going to be the same thing. It's actually the same. Still A over B. The only thing that is now changing is how I create the ratio of their areas. The ratio of their areas is I'm going to take their scale factor, A over B, and just square both those numbers. So the ratio of the area is just going to be A squared over B squared. This is my big concept for today. All I need for us to know. Okay? So here is my first problem. The trapezoids at the right are similar. The ratio of the lengths of corresponding sides is 6/9. Or we can simplify that to 2/3. The reason I know that without even being given that information is these two parts here are in corresponding positions. And I've already been given the fact that they are similar in the question. So their scale factor, I'm going to say, is right here. I'm going to use different color. I'm going to use blue. So 2/3. That's the answer you would have given to me in chapter 7. Their ratio is 2 to 3. So now I want to take it a step further. I want to know what is their ratio, smaller to larger, of the perimeters. Well, what did I just say about the scale factor and the ratio of the perimeters? Wake up with me. What is true about the scale factor, Yana? They're corresponding. So what is to me true about the scale factor as well as the ratio of the perimeters? What's my answer going to be? Yeah, it's 2/3. They're the same thing. That's what I just talked about. If your scale factor is A to B, then it's the exact same thing as the ratio of your perimeters because it's still a linear dimension. All right, then, so what is the ratio of their areas going to be? What do I need to do to my scale factor to get my ratio of my areas? Joey?
Square them to 4/9.
Very good. I'm just going to square both these numbers. So my ratio of my perimeter is 4/9. Questions on that? All right, it is now your turn. You have 2 got it questions, so it is now your turn. Okay. All right, should we check your answer when you first got it? Yes? Okay. All right, so your ratio was 5 to 7, so I want the ratio of their perimeters. And because it specifically said from larger to smaller, you have to give me this one answer, a ratio of 7 to 5. If you had 5 to 7, I'd have to take off a whole point because you did not read the instructions. Questions on A? All right, B. Ratio of their areas. You square their scale factor, and so you're going to get 49 to 25. Questions on that? Okay, very good. So we're just going to take these types of concepts a little bit further now in the next 3 examples, okay? Because that is a key idea throughout this entire lesson. The area of the smaller regular pentagon is about 27.5 centimeters squared. What is the best approximation for the area of the larger regular pentagon? Okay, first off, what do you know about regular pentagons? What does it mean to be regular? What does it mean to be regular, Yana? Very good. They're equiangular and they're equilateral. So what does that tell you about regular pentagons? What does that tell you about regular pentagons? Jimmy?
They're similar.
They're similar. Because they have all the same angle measures, because Yana said they're equiangular, these 2 figures are going to have to be similar, okay? So we know that they are proportional to one another. So the first thing that I would like for us to create is create the scale factor, okay? So scale factor. What's the scale factor going to be for these 2 pentagons? Go ahead, Jimmy.
5/2.
How'd you get 5/2?
I did 10/4 and then I simplified.
Very good. So then you divided it. They are simplified. So if you have their corresponding side lengths are 10 and 4, it simplifies to 5/2. So this is your scale factor. Scale factor is the same thing as which ratio? Perimeter or area? Perimeter. Okay, so just as a side note, this is also the same as the ratio of the perimeters. Okay? My whole question, though, is dealing with area. So if I'm dealing with area, what do I need to do to my scale factor to get the ratio of my area? What do you do to the scale factor, Yana? You just square both numbers. Very good. So the ratio of my areas is going to be equal to, what's 5/2 squared? Very good, 25/4. Okay? So far my question looks the same as my first example, but this one took it further. What I have been given is the area of the smaller pentagon, and I need to find the area of the larger pentagon. So what I need to do is create a proportion like we did in chapter 7 to find the missing area. So I'm going to take my ratio of area, 25/4, and I'm going to set this equal to the ratio of the actual areas. So I've been given the smaller pentagon has an area of about 27.5. Is that going to go in the top or the bottom of my proportion? Why is it going to go in the bottom? I agree. 27.5 goes here, but why? Why couldn't I put it in the top, Anna?
Because it's been performed, that's what
Very good. It has to go with the 4 because that is the smaller pentagon. So you have to stay consistent. So I'm solving for x, and x represents the area of the larger pentagon. So there's your proportion. So what do you got to do to solve your proportion? Cross multiply. And all I'm really going to do is just multiply the 27.5 to the other side. So in my calculator, what I'm typing in is 25/4 of 27.5, and that'll get me my answer for x. Answer for x, what did I get here? I got 171.875. Yes, don't want to lose a half a point. What am I going to do? I want to lose half a point.
Inches squared.
Ooh. Inches or centimeters? The whole question's been about centimeters. So this whole thing is dealing with centimeters squared. Questions on how I produce the area of the smaller pentagon. Okay, please note, because the question dealt with area, I had to find the ratio of areas. All right, it is now your turn. Here's your got it question. Okay. You ready to check your answer on this one, guys? All right, let's check it out. So, I have an answer of 54 inches squared. 54 inches squared. Questions on this one? Susie? So if the perimeter, the scale factor is 3/4. That means the ratio of the areas is 9/16. I have been given the area of the larger is 96. So if I have 9/16, it's going to be equal to x over 96. Then all I got to do is solve for x. Good? Any other questions? All right, so now I'm going to do example 2, but with some words associated with it, okay? Making it a little bit of a real-world problem. During the summer, a group of high school students cultivated a plot of city land and harvested 13 bushels of vegetables that they donated to a food pantry. Next summer, the city will let them use a larger, similar plot of land. There's that key word. I saw the word similar, so I know I'm in section 4. In the new plot, each dimension is 2.5 times the corresponding dimension of the original plot. What was I just given to you here? 2.5 times. So what was I given? I heard it. The scale factor, very good, because everything's getting enlarged 2.5 times. How many bushels can the students expect to harvest next year? Okay, I do not need to know the actual area of these plots of land because I have been told that it is similar. And because it is similar, all I really need to do is create those ratios, create those proportions, okay? So let's start off with the ratio of the dimension, also known as the scale factor. And as Lindsay pointed out, that was given to me. So what is the scale factor that I'm going to use? What is the ratio? Okay, so you're doing 5/2. So I'm imagining you started off with 2.5/1, We don't really like to see decimals and fractions, so Phoebe automatically converted that to 5/2. Good job, Phoebe. All right, so we now know our ratio of our dimensions. Area is important in this particular word problem because are you only planting bushels around the perimeter? No, you plant bushels all across the land, which means you actually need area in this problem. So what do I need to do to my scale factor to get my ratio of my areas? Square them both. So if I have 5/2, when I square that, that gets me what? 25/4. Okay? So we have 25/4 is the ratio of our areas. Now, we don't actually have any area information, but what I do have is how many bushels have been planted. Okay? So if I have 13 bushels planted, I was able to plant 13 bushels on a smaller plot of land. So that's what I'm going to plug into my proportion, 13. Now the biggest question is 13 going to go on the top or the bottom for my proportion? Top, bottom, very good. Because that was my smaller plot of land. And the city thinks I'm doing such an awesome job that I get more land. So my x is going to go in the numerator. And then what do you do to solve a proportion? You cross multiply. So I'm just going to multiply the 13 over to here. So I really have 25/4 times 13 getting me my x value. And when I typed that in, I believe I still get 81.25. Did you get 81.25? Now I'm not sure how much you know about farming, but you can't have 1/4 of a bushel. Just like you can't have 1/4 of a person. Okay? So what I'm going to do is, for the sake of this question, is I'm going to round this to being an answer of 81 bushels. And notice that I've included my units in this situation as bushels. Bushels are basically a bunch of vegetables. Questions on this word problem? Yes, Leah?
If it had been like 81.75, would you still round down?
I would probably round down in this type of problem, okay? I would like to believe that if there is a question that exists on your assessment with this, I made sure that it was not going to end in such a funky number. But I'm going to say, for the sake of the air test, because I have zero control over what appears on your air test, I'm going to say adhere to probably normal rounding, just because I totally don't know what they're going to do. And typically what they do for air test is they create a threshold. And so it's kind of like plus or minus answers, and they'll typically give some partial credit if you didn't round correctly. Don't quote me on that, okay? All right, it is now your turn, okay? Here is your got it question. You have 2 parts. Okay. Are you ready to check this got it question? Okay. All right, let's check them out. So in got it A, you should have had $6.94 as your answer. Questions about got it A? Okay, and got it B. The reason why it had to specifically say it was 2.5 times the corresponding dimensions is because if it didn't say that part, none of the sides would have all been proportional. Okay, and they got to be proportional in order to create a similar relationship. Good on that? All right, so for these last two examples, we've been doing the forward motion. You find the scale factor, you square the scale factor to find your area ratio, then you use your ratio of areas to find area. The last example, we're going to go backwards, okay? We're going to be given areas, and we need to get back to the root and find the scale factor, okay? So the triangles at the right are similar. What is the scale factor? What is the ratio of their perimeters, okay? So notice I have been given area. And because I have been given area, the easiest thing for me to do is to start off by finding the ratio of my areas, okay? So, ratio of my areas. My ROA. What's my ratio of areas going to start off looking like? Create a ratio for me of their areas. What do you want it to be?
50 over 98.
Okay, so 50 over 98. The first suggestion I'm going to give to you is always simplify your fractions, okay? Simplify them because they're going to make your life a lot easier, okay? So I first see 50 over 98, but I know 50 and 98 are both divisible by a number. What number am I thinking? 2. So if I divide both those numbers by 2, I get 25 over 49. This is my ratio of my areas. So now that I have my simplified ratio of areas, it's a lot easier for me now to downgrade it to being a ratio of perimeters. To go from perimeter to area, what did you do to the ratio? To go from ratio of perimeter to ratio of area, what did you do? You squared it. So if we want to go from ratio of area to ratio of perimeter, what are you going to do? You're going to take the square root of it. And are both of those numbers perfect squares? Look at that. That's why we wanted to simplify it first, okay? So we're going to take the square root of both of those numbers. So the ratio of my perimeters is going to be what? 5 over 7. Very good. It also asked me for my scale factor. But we know better. What's the scale factor? It's still 5 over 7. Because this is the same thing as the ratio of my perimeter. Because they both deal with linear dimensions, they both produce the same answer, okay? So my ultimate answer on this guy here is 5 sevenths. Questions on that? All right, here is your turn. The area of two similar rectangles are those two numbers. What is the ratio of their perimeters? If it makes you feel better, your ratio will have to have a square root left in it. So always double check to make sure you simplify though as far as you possibly can go. All right. Ready to check? Okay. Now I'm going to show you. The poor souls of the textbook decided not to simplify their fraction at first. So by not simplifying their fraction at first, they had a lot of work to do by simplifying big square roots like that guy there. So one way that your answer could have been presented, because it didn't tell you what order to do it in, is I could have taken 5 times the square root of 5 divided by 3. So that would have been from larger to smaller. Okay? So smaller to larger would have been 3 divided by 5 square root 5. However, this makes me cringe. Why does that make me cringe?
Radical in the denominator.
There you go, because there is a radical in the denominator. So if I were you and your answer just ended up like that, I would just say, let's just flip it and go from larger to smaller. Does that make sense? Okay, questions on the material today? Not so bad? All right, my friends. So what you're going to do now is you're going to log on to Schoology. You may use your notes. You're going to complete the 10-4 check for understanding. Then when you are finished, at my desk I have your questions for the coloring activity. I have noted on the board which questions you have the ability to complete. Okay? So look on the board when you are finished with your check for understanding.